Yeah. Is it clearer now? If it is clearer now, comment again. Hopefully, the voice should be. Uh, so can you guys listen? Yep. But first we need to sort out the voice thing. So is it clear now? And then I can go ahead. Okay, it seems it is clearer now. Okay, okay. It seems it's clear. So I'll start again. Nothing major has been covered. I just covered that some of the basics which most of you know. Area of the circle is pi r square. Perimeter of the circle is 2 pi r. If you have to find out an area of a sector, like area of this portion, a part which have been cut out, then what you do is you take the total area pi r square and you just take whatever is this angle theta and you multiply by theta by 360. So if this were 60, it will be multiplied by 60 by 360. So that's where you will get the total area. If I had to calculate only the area of this part, which is marked in red, then you take the total area pi r square theta by 360 and you subtract the area of this particular triangle. And then you will get that area. So once we come to questions, we'll see if such examples are there. But this is also, I want to clarify the format that we are going to follow. So we'll do some of the basics and few good questions today. And in the next class, we cover whatever is remaining part of the basic. And then we'll do a lot of difficult questions next class onwards. Okay. So that will be the format of the session. So this is another property. So we'll cover some of the more important properties which are regularly asked in questions. There is a circle, PQ is a chord of the circle. If you join the midpoint of the chord with the center of the circle, this angle is 90 degree. This is a property which is regularly used. If you want to derive how this happens, you can just do it this way. If you join these two parts, this is radius of the circle, this is also radius of the circle. You have joined it to the midpoint, so these sides will be equal and this is common. So both these triangles are congruent and that would result in that these two angles have to be equal and then they will be 90 degree. So the property is this: if you join midpoint to the center of a circle for a chord, then it makes an angle of 90 degree. You can write it the other way also. If a line from the center makes 90 degrees on chord, it will divide the chord in two parts. If it might seem I am going a bit fast, if it does, it's your responsibility to comment and let me know that I am going too fast. Let's look at some question. What is the distance in centimeter between two parallel chords of length 32 centimeter and 24 centimeter in a circle of radius 20 centimeter? So let's see what it's saying. When you have a circle of radius 20 centimeter, as soon as I start drawing chords like this, let's say I keep drawing chords, the length of the chord keeps reducing, right? So if there is a chord of length 32 centimeter, it can either be on this side or it can be on this side also, because this side also it will keep reducing and at some point it will reach 32 and same way it reached 32. So what it is saying is ki, what is the distance in centimeter between two parallel chords? So there are two parallel chords, one is of 32 length and the other one is of 24 length. So let's say this is of 24 length. And what is the distance between the two? So we'll use what we just studied. We know that if we join midpoint of the chord to the center, it will make a 90 degree angle. These two chords are parallel, so I can join this one also. So this is 90 degree, this is 90 degree, and it's dividing it into two. So if the chord is of 32 length, this side will have 16, this side will have 16. And same way, if the chord is of 24 length, we'll have 12 on this side and 12 on this side. We need to find this length in between. How much is this particular length? Let me zoom in a bit. So we are told to find what is the distance between two chords whose length is 32 centimeter and 24 centimeter. So this is 12, this is 16. We need to find this particular length. We are also given the radius of the circle. So the radius of the circle, if I join this, it becomes the radius of the circle. The radius of the circle is 20. So you know this is 20, this is 16. So what will this length be? Pythagoras theorem say we know that this is 12. So this length is 12. And then for the bigger triangle, you can make this triangle also. And here again radius length will be 20. This side is 12. So what will be the longer side? It will be 16. So the longer side will be 16. And hence the distance between these two chords will be 16 minus 12, which will be equal to 4. So that is one way, but the distance between the two chords can be found in the other way also. Like it's not given that both the chords are on the same side. So you can have a situation where the 32 side chord is this side and we have the 24 size chord on the other side. In which case the distance won't subtract, it would add. The 32 one is 12 centimeter away from the center, and this one will be, if you do the same thing, this is 20, this is 12, so this comes to 16. And hence the distance between the two chords will become 16 plus 12 equal to 28. So there are two possible answers. It can be 4 and it can be 28 depending on which side the chords are. And I think the option of this question gives both the options. It says 4 and 28 are possible options. So that is true. 4 and 28 are the possible options. So that you need to bear in mind whether the chords are on the same side or on the opposite side. Is it clear? I can just pause for a bit here in case there are some doubts, etc. As I was saying earlier, Facebook keeps making changes to its live platform, and so I am continuously struggling with the settings and etc. But I think you guys are able to hear me properly, and if this question is clear, we can move on to next stuff. It's not very complicated. You can do it yourself and it should be clear. So that's the other thing. I have repeated it in previous classes also. I'll repeat it again. The purpose of this session is not to understand everything here, but to understand it enough so that you can revise it later and understand it completely. And you need to revise it. Otherwise you will forget and then it won't be very helpful. So you need to revise it at least twice, if not once. Let's look at the other question. This one actually you can attempt yourself. The question says the distance between two parallel chords of length 6 cm and 8 cm is 7. If the chords are on opposite side of the center of the circle, what is the circumference? So here you have been given the distance, but you haven't been given the radius of the circle. You are asked the circumference. So once you know the radius, you can get the circumference. So what we have been given is that the chord's length is 6. So let's say this one is there which has length 6. There is another one on the opposite side whose length is 7. Length is 8. There are two chords of 6 cm and 8 cm, and the distance between them is 7. So this total distance is 7, and then we need to find the radius. So how will we do it? You can do it the same way. This will be radius. This will be radius. If we are joining it at midpoint, these will be half of the total. So if total is 6, this becomes 3 and 3. This becomes 4 and 4. And then you know the total distance between them is 7. So if I had to do it properly, I would put this one as a, then this becomes 7 minus a, and then using Pythagoras theorem, you know, you get two equations: 4 square plus 7 minus a square equal to r square, and 3 square plus a square equal to r square. And you can solve both of them to get a and r. But even by observation, if you know enough Pythagorean triplets, this one is fairly easy. Because it's 3, 4, so and the sum is 7. So if we have 4 distance here and 3 distance here, it will satisfy the equation. R will become 5 for both of them. And so we know the radius to be 5, so the circumference becomes 10 pi or 2 pi r. So you can solve the equations, or by observation also you can do. Exam mein itna aasan nahi aayega, but at least you get some idea how you can solve such questions. So examination questions are basically a combination of easier concepts. So many people ignore easier questions, or they do it once and let go of it. That's not correct. If you know the easier questions by heart, you will be able to spot such situations in the more difficult questions. So this would again be classified as an easy question. It's not a very difficult question, but you need to know it so that you can do better in the more difficult questions. This one is not so easy actually. Should I do it today? Let's see. So we have been given two chords of length 6 each, and the circle is of radius 5. Now you need to find QS, or this particular distance. How do we find this particular distance? We know that the circle's circle's radius is 5, and there are these two chords of length 6 each. We know one thing about chord, that if we join from the midpoint, it will be a perpendicular. It will be this line actually, and this line will be a straight one, as in this angle will also be 90. So proving this will be a bit tedious, but if you join it to midpoint, this is equal to this line is common, and this side is 6 each, which means these parts will be congruent. So if you, it's a very it's something which you need to understand, but a lot of people will be able to solve the question without understanding this. What most people will do is they'll join P and O and just assume that it will split QS into half. That is not a given. That needs to be proved in a strictly mathematical sense. But still question solve ho jata hai, so nobody bothers. But you can prove it just by saying that if this is X, PXQ and PXS will be congruent triangles. So now once you have made this is a straight line, then you can solve the question. We know the total distance will be 5. This distance will be 5. Okay. So we need to find QS. So let's assume this length to be A and this length to be B. Then this length becomes 5 minus B. And since this is also 90, now again we get two equations. We get A square plus B square equal to 5 square from this particular triangle, this triangle. And from the other triangle, we'll get A square plus 5 minus B square equal to 6 square. And then you can solve these two equations to get the answer. The one way to solve will be just subtract the equations. You get B square minus 5 minus B square equal to, we can do it the other way. 5 minus B square is equal to 6 square minus 5 square, or 36 minus 25, 11. And this one you can apply A minus B, A plus B also if you want. So this becomes 5 into 5 minus 2B equal to 11. And hence you get, from here you can solve for 2B. 2B will be 5 minus 11 by 2. 5 minus 11 by 5, or 25 minus 11. Whatever it comes to, I think it will be 14 by 5. And then B will be 14 by 10. 1.4. So you can solve these two equations to get, once you get B, you can also get A, or you can solve directly for A, and then you will get 2A, which will be the length of QS. So clear? If you face any doubts, please comment, let us know. Class may actually asking doubts is much more tougher than here. So if you have any doubts, you should comment or something, and I'll be happy to go through it again. But it's nothing very complicated. Again, same concept. We know that the perpendicular will split it into two parts. We knew this will be the total radius. So what we did was we assumed one part to be B, the other part became 5 minus B because the total length is 5 minus B. We assumed this half to be A, and then we had two right angled triangles. So we did Pythagoras theorem twice. A square plus B square equal to 5 square, and A square plus 5 minus B square equal to 6 square. And so we got two equations and we solved to get the answer. Now I'll move ahead. There is this property of circles, very common. Most of you probably know. If you don't, you can find out. So there is a chord PQ. If it subtends angle theta at the center, then it will subtend angle theta by 2 at the circle, and it will subtend the same angle everywhere. So if I draw another angle from here to this point, this angle will also be the same. It will be theta by 2. So angle at center is double of whatever is the angle at the circle for a chord, if it's on the same side. So if we are doing it for PQ, all the angle on this side will be the same. But if I made an angle on this side, it won't be theta by 2. right? Because that's on the opposite side. So that will actually be of the opposite side for this also. So if this is theta, there is 360 minus theta, and it will be half of that. So this will be 180 minus theta by 2. And actually, this derives the relationship for cyclic quadrilateral also. So I'll not confuse you right now. We'll first understand the first part. We'll look at it later. So if you make theta, if you are subtending 70-degree angle at the center, the angle at the circle will be 70 by 2 or equal to 35 degree. Okay, so this is fairly clear. And it should be on the same side. So this angle won't be 35 degree. This angle will not be 35 degree if you are making 70 degree at the center. Actually, what it will be the opposite of this. So if this is 70, then 360 minus 70, this angle becomes 290, and this will be half of 290 or 145 degree. And from here, you can also create that relationship that for any cyclic quadrilateral. So a cyclic quadrilateral is, if this is a circle, a quadrilateral with all its vertices on the points of circle is a cyclic quadrilateral. This would be a cyclic quadrilateral because all points are on the circle. Then the sum of opposite angles will be equal to 180 degree. So if this is x, this is y, x plus y will be equal to 180 degree. That's a property of cyclic quadrilateral, and that can be derived from here, that the center angle is total 360, half of which comes on this side, the other half comes on that side, and the sum will become equal to 180 degree. Question like then, question set would become more clearer. Most of you anyway know this property, so there is nothing new here. O is the center of the circle that we have. So you have a center here, and we have to find this angle. So we have to find this angle. We have been given two angles here. This is 35 degree, this is 50 degree. And now we have to identify what we can do. So how will we go about it? We know that this is the radius. So this is also the radius. So this triangle becomes an isosceles triangle. And if it's an isosceles triangle, this is 50. So this angle will also be equal to 50. And if this angle is 50 and this is 50, so this angle becomes 180 minus 100 or 80 degree. So this angle we know 80 degree. We have to find the one on this side actually. We have to find this one. So what else can we do? We also know this triangle will be isosceles because it's the radius. So OPQ will also be isosceles. So if this is 35, you get this angle to be equal to 35. So this is 70. So the total bigger angle becomes 110, out of which 80 is on this side. So you remaining will be 110 minus 80 equal to 30. So again, not very complicated, should be able to do it mentally, but I'm still solving it so that if you're not very comfortable, at least you can attempt these questions to get a bit more comfortable with circles and various angles and everything. If I were to divide the circle into 4 parts, what would be the angle that each sector will subtend? So if all these parts are equally divided, what would be the angle at the center? What would be this angle if I have divided it into 4 equal parts? So this angle will be just 360 divided by number of parts. Okay, so if I have divided it into 4 parts, the angle at here will be 90 degree. If I had divided it into 6 parts, let's say these were divided actually into 6 equal parts, whatever, just assume that these are 6 equal parts, then this angle becomes 360 by 6 equal to 60 degree. So basically however many equal parts you divide, that would be the angle that you will get at the center. So this is the same question. Circle is divided into 8 equal parts, and we have to find what is the angle at the center. So by 1 part, so if you are dividing into 8, the angle at the center will be 360 by 8 or equal to 45 degree. 45, right? Yeah. So it's just, you can assume like there will be 8 parts creating these angles and all 8 have to be equal. So there's nothing fancy here. So all 8 have to be equal. So the number of the angle for each becomes 360 divided by 8. Now this is a slightly better question which can be asked in the exam also. So this is what the question is saying. The question is saying we have divided the circle into 8 parts. Okay. And then we have joined a few sides. So I have joined these two sides. So dividing, so this is equal to 3 out of the 8 part. So this is 3 out of 8 part. And then I have joined A and B, which is equal to 2 out of the total of 8 parts. And now I want to know how much would CO be, or this particular angle be. What is the value of this particular angle? Now, ये थोड़ा सा, it requires a bit of thinking. So let's do that. How will we do it? If you just join this part, can we get this angle? So this is the angle subtended by this particular part of the circle, which is 2 out of 8 parts. This part is subtending an angle here. What would that angle be? We know what it will subtend at the center, right? So it's 2 out of 8. So 360 by 8 into 2 or equal to 90 degree. So at the center, this part will subtend 90 degree. So what will it do at the circle? We discussed theta at the center, theta by 2 at the circle. So if it is 90 at the center, this particular angle will be 45 degree. Same way, if you want to calculate this one, this is the angle subtended by this arc, right? This angle is subtended by this arc. So what will be the angle subtended at the center by this arc? That will be 360 by 8 or 45 degree. So here it will do 22.5. So this becomes 22.5. And now that we know both of these, we can calculate this, which is just 180 minus 45 minus 22.5. And then you will get whatever be the angle, whatever it comes down to. I think it's, how much is it? 90 plus 22.5, 112.5. So that becomes your answer. Not so straightforward. Once you know the solution, it's pretty straightforward, but doing it yourself, it might be slightly more trickier. Let's look at this question. Here we have to do a bit more work. So what has been given to us, same concepts will apply, similar things will apply, but just staying on the topic of having regular shapes around a circle or dividing a circle and so on. Shortest diagonal of the, this should not be easier. So there is a regular hexagon, all sides are equal inside a circle, and its shortest diagonal is 3 units. So what will be the shortest diagonal? This one will be the shortest diagonal. So hexagon will have other diagonals also, like this will be the longer diagonal, but this will be the shortest diagonal. And length of this is given as 3 units. We have to find the area of this shaded region. How will we do it? Let's assume that the radius of the circle is r. So this value is r. Okay. This is r. What would this angle be? There are 6 sides, each subtend equal angle, so each will be doing 60 degree. So the total angle here becomes 120 degree. The total angle of this is 120. This side is 3. This is also r. So now you can calculate r basically using this. You can use cosine rule, which we discussed earlier, or you can just use basic trigonometry also, that if you split this, this becomes 1.5, this will be 60. And so you can use sine 60 is equal to perpendicular by hypotenuse, or 1.5 by r. So you can use either way and you will get the value of r from there. Okay, so we will get r equal to 1.5 by sine 60. And sine 60 is root 3 by 2, which you should know. So this becomes root 3. So my radius is root 3. After that, so it's easy. We discussed how to find an area in the beginning itself of this kind of a shape. So let's say we have found radius is equal to root 3. Now I need to find that area. And that's easy for me, right? I know this radius is root 3. and I know this angle is 60. Given its isosceles, this angle will also be 60 and this angle will also be 60. So it's an equilateral triangle and the area of the sector. So area of the sector will be pi r square into 60 by 360, theta by 360 we have decided, which will be 1 by 6, minus area of the equilateral triangle, which will be root 3 by 4 a square, or root 3 by 4 root 3 square. So this will be the answer. Now you may need to simplify it depending on how the question is asked and so on. It should not be very difficult actually. Pi by 2 minus 3 root 3 by 4. So this is what you get. But slightly more work needed, but not very tough work needed. So hopefully it's all clear. I'll just zoom out a bit so that you can see the entire thing. And I can take a pause here because I'm going through it a bit quickly. So in case if you have any doubts, etc., you want me to go through a question again or have any doubt, feel free to question and ask. In fact, I'll take a pause at the next question. So I'll just go through one more concept and then we'll take a pause. So this is a very basic concept. Most of you know this, that a diameter subtends 90 degree at the circle. So if a diameter is subtending an angle, it will always be 90 on both sides, because both sides are same for the diameter. So this angle will always be 90. And if it is 90, then the line will be diameter. Sometimes you forget the opposite side of it. So if it is 90, then the line will be a diameter. So this is the question. Here I'll pause for a second so that you can ask any doubts also if you have. But the question is, PS is the diameter to both of these circles. So the PS is the diameter to both of these circles. And the diameter of smaller circle is 4 by 5 times the diameter of the larger circle. And you are given QR is equal to 3. So this QR is equal to 3 you have been given. This is Q. And you need to find this particular length. So think about how you will do it. I'll take a 30-second, 1-minute pause in case you want to think back over what we have discussed. If you have any doubts, any questions, or any suggestions, you can talk about that as well. So I haven't got any comments, so I'm assuming things are clear till now. Any answers for this question? Any method how to solve, what to do? Yeah, similarity is the idea. So this is the diameter. So we'll just use what we learned just now. If I join these two parts, since it's a diameter, it will subtend 90 degrees. So this angle will be 90, this angle will be 90. Okay. I know that the diameter of the smaller circle is 4 by 5 times the diameter of the larger circle. So I can assume this length to be 4x, this length to be 5x. And if I, let's say, put this T, the triangle PTQ, or this triangle, will be similar to the bigger triangle PSR. These two triangles will be similar. How? You can very quickly verify. This is 90 degree. This angle is common. So one angle is common, the other angle is also constant. So this angle will also be equal. So all three angles for both the triangles are similar, which means the sides will be in the same ratio. So PT by PS, this won't be 5, the total will be 5x. So this length I can assume to be x. PT by PS will be equal to PQ by QR. and PQ is the length I need to find. So PT by PS is 4x by 5x or 4 by 5, and that is equal to PQ by QR, which is PQ plus 3. And using this, you can get the answer. Plus PQ is equal to 12. So this length will be equal to 12. So again, that is the reason why triangle properties are fairly important. They get applied in various other places. Once you have become comfortable with them, solving questions on circles or specifically on quadrilaterals is much more easier. So worth spending extra time over there. But this question is clear. The other property, I think most of you know, but still we'll cover it. A tangent from an external point. From an external point, you can draw two tangents to the circle, and both the tangents will be equal. So this tangent and this tangent will be equal in its length. How do we prove it? Let's say this is the center, the tangent. So this will be 90 because the definition of a tangent is that. So this angle is 90. If you look at these two triangles, this length is constant. This is R. So one side is equal, this length is common, and one angle is same, which is 90 actually. So in that case, we can very confidently say that these two triangles are congruent, and so GF will be equal to GH, or the length of the tangent will be same. So if this tangent length is 10, then this will also be 10. Question dekhte hain. So the question here is, and it's a very common question, we would have come across some version of it somewhere or the other, but we'll solve again. So we have been given 4 points A, B, C, D, all of which from which we have drawn tangents to the circle, and we are given the entire length of this side. So this side is 12, this side is 10, this side is 8, and we have to find this side, how much, what this will be. Kaise kare? So how do we do it? We know that the length of the tangent is equal. So this part will be equal to this will be equal to this, and so on. So let's start from somewhere. We'll assume this length to be x. So this is x. So the other side becomes 8 minus x, which means this also becomes 8 minus x. And that means this becomes 10 minus 8 minus x, or x plus 2. So this is x plus 2. If this is x plus 2, this is also x plus 2. So this is x plus 2. And so this becomes 12 minus x minus 2, or equal to 10 minus x. And if this is 10 minus x, this side also becomes 10 minus x. And this part we assumed x, so this will also be x. Hence, the length of the other side, which is not known, is 10 minus x plus x, or equal to 10. So we have just used one property here, that the length of the tangent is same from an external point of view, and that's why we are able to do this 8 minus x. So this is also equal to 8 minus x. This is x plus 2, so this is also equal to x plus 2, and then this is 10 minus x, so this is also equal to 10 minus x, and it cancels in the end, and we get the answer. There are a lot of applications of these questions. We'll do some today, we'll do a lot of them next session. So important properties. Let's look at this question. So we have a right angle triangle. This triangle is right angled, and we have been given all three sides. Ignore what is written on the triangle, etc. But we have been given all three sides, A, B, and C, where C is the hypotenuse, and we need to find the in radius in terms of the length of the side. So what will be the radius of the in circle? And how will we do it? Let's say this length is R. This is also R. This is a point from which there are two tangents. So both of them will be equal. And anyway, this is 90, this is 90. So this also becomes R, and this becomes R. If this is R, what is this remaining length? A minus R. And since it's a tangent from an external point, this side also becomes A minus R. Similarly, here this length becomes B minus R. And since it's a tangent, this side also becomes b minus r. And the sum of b minus r and a minus r is equal to c. So you can put c is equal to b minus r plus a minus r. And from here you get r is equal to a plus b minus c by 2. So we have got in circle in terms of a, b and c, which was asked. It's an important relationship because you might be asked a difficult question which has this application. You might be asked question on in circle, in radius, where you have already been given the sides of the triangle, and you don't need to give all to 3 also, right? Because you know that c is equal to under root a square plus b square. So you might be asked if one side is 4, the other is 6, what is the in radius? Or there might be other ways also to put it. To find it, you can equate areas also to get the in radius. But this is also an important relationship. So know the definition, remember the relationship also a bit. Don't learn it by heart, but just how it was derived, some idea, and that should be fine to see you through. But I felt this is a good question to practice and get comfortable with the idea. Common tangents of two circles. So if there are two circles, they can have at max 4 common tangents. They can have less also, but at max 4 common tangents. These ones will be called direct because they are on the same side. So this length, this one and this one, they are on the same side of the circle. So they are called direct tangent. And then there are two of this sort, which are transverse tangent. So they are for one, the circle is on this side and the other circle is on the other side. So there will be two of that sort. So total 4, out of which they are split like this. Let's look at a question. So there is a circle and there is another circle which is adjacent to it. What we have been given is that the ratio of radius is 2:3. So if the ratio of radius of both the circles is 2:3, we need to find AD. So D is here. D is here. So we need to find this particular distance, this distance, if OO dash is equal to 32. So we have been given OO dash is equal to 32. So this length is 32. Since we know that ratio of radius is 2:3 and this is sum of radius, so we can actually calculate radius from here. How much would this length be? This will be 3/5 into 32 or 96/5. How much does it come to? Whatever. So 96/5, and the other side will be 2/5 into 32 or 64/5. So these are the two radiuses. So we got the radius, but we need to calculate this length. And how can we calculate this length? Again, we'll use similarity. So this angle is 90, this angle is 90 because it's a tangent. Again, same thing, this angle will be the same for both, and which means two angles are same, so third angle will also be same, and the sides will be in the same ratio. So what is the ratio for the triangles? O dash B by OC, which is the ratio of the radius, is known to us as 2/3, is equal to AO dash, which we need to find, divided by AO, which is AO dash plus 32. So fairly similar question it becomes to the, although the situation is entirely different, the way equations are formed, the way things are done, it becomes fairly similar to what we have done previously. And again, we can solve this to get the answer. 2 AO dash plus 64 equal to 3 AO dash. So you get AO dash is equal to 64. So this length becomes 64. And we didn't have to find AO dash, we had to find AD. So we'll do 64 plus 64/5. And that gives us whatever, 12.8. So 76.8 as the final answer. Clear? The purpose of showing you these questions is not because they're very difficult to solve, but because these questions have techniques which are very commonly used. Many a times you'll come across circles where you will make those tangents and then do these similarity kind of things. So getting exposed to such things will help you solve the more difficult ones much easily. Just give me a second. Yeah. This is another question. Similar concept, you can actually try this one. Here, the radius is given, the angle is also given. So this total is 60. So this particular is 30 degree, and you need to find x. If you are comfortable with trigonometry, this is 90 degree. You know this is 90 degree. So if you're comfortable with trigonometry, you can very easily calculate this length and this length, because you know sine 30 will be equal to, if this I assume as y, will be equal to 10 by y, and it will also be equal to 30 by x plus y. And you know sine 30 is equal to half. So half is equal to 10 by y, implies y is equal to 20, and 30, so half is equal to 30 by x plus y. So x plus y will be equal to 60, and given y is 20, x becomes 40. So you can very easily, even in within seconds, you can calculate that this distance will be 40. You will need to do this. If not in CAT, in other MBA exams, if you turn up, they do expect you to know the basic questions almost by heart, and they'll ask you similar questions, and you should be able to do it within seconds, 30 seconds, 40 seconds, and so on. Even in CAT, you would be expected. Specifically, sometimes they would like have this figure and have 4 options, so you can't do all the calculation. You can't take time and do all the calculations, so you need it to be fast. And if you do it this way or similar ways, if you have practiced all these questions properly, you should be able to do that during the exam. There are a couple of more things which we can cover in geometry theory. There isn't a circle theory. There isn't a lot which you need to know actually. So it's much more easier than triangles in a way. But if you don't know triangles, you won't understand circles properly. So we'll cover the theory part today almost completely, and in the next session we'll only do questions. We'll do 10-15 difficult questions. So this is alternate segment theorem. You have a tangent from T to A. If you have a chord here from A, then the angle it will subtend on the other side will be same as this angle. If the angle between the chord and the tangent is alpha, it will subtend alpha on the other side. So that's all there is. It's a very useful theorem. Specifically, whenever you see a question with tangent and angles in that, think about alternate segment theorem. There's a big chance that it would be using it at some point. Let's see this question. So there is a point G from which we make these tangents F and H. Now we have to find the sum of these angles, IFG plus IHG. So how can we add up these two angles? What is the sum of these two angles? And the only thing we have been given is that this angle is 50 degree. So how do we do it? The way to do it is you join this, and now you use alternate segment theorem. How? Let this angle be alpha. So if this is a chord and this is a tangent, the angle subtended on the other side would also be alpha. So this angle becomes alpha. Same way, if this is beta, the angle subtended on the other side will also be beta. Okay. So now look at the triangle FGH, the big triangle. The sum of its angles have to be 180 degree. So it is 50 degrees plus alpha plus beta, because that angle is alpha plus beta and the other angle is also alpha plus beta. This is equal to 180 degree. So from here you can actually get alpha plus beta, which is 130 by 2 or 65 degree. And you don't need to know exactly alpha and beta, because the question is asking you the sum of these two angles. And you can get it from here itself, that alpha plus beta is equal to 65 degree. So that is the final answer. It's not as easy as it seemed right now, because right now I showed you the correct path. When you will try and do it yourself, you would see 1,000 other ways to go about it which would not work. And that happens to everybody, but better students have spent enough time solving different kinds of questions that they're easily able to zero down on the correct way to go about a question. So that's the only difference. If it's clear, I can move on. I'll just go through it once more. What we are using is the alternate segment theorem. We are given that angle is 50 and we have to find the sum of this angle and this angle. but we also know that if this is x, then this angle becomes x. If this is y, then this becomes y. And if the sum of these four angles have to be 130 degrees, because it's a triangle and this angle is 50. So 2x plus 2y becomes 130, which becomes x plus y becomes 65 degrees. This one is a slightly more difficult adaptation of the same idea. So there are two circles, they are adjacent to each other and they have a chord running through. And what we are given is that length of this chord on this side is 10 and it's 4 on the other side. Length of this chord on this side is 8 and we need to find what is this particular length, x. Any ideas how we can go about it? I have been speaking for a reasonable period of time now, so I'm hoping some of you would be able to help me out here. I'll take a pause. If you have any doubts, etc., also right now is the right time to ask. Brandu, you don't know why you did what you did. You did it because you have seen similar question in a different context. But my guess is you have no idea why you did what you did. The answer is correct actually. Let's see how we can get there. So these 2 points circles meet at a point, right? We can create a tangent here. We can the tangent is not given, but we can assume there will be a tangent through this point, which will be tangent for both of these because it's the same point. Now, if you create that tangent, what happens? If this angle is theta, then this angle will be theta because alternate segment. This is a chord, this is a tangent. So if the angle here is theta, then it will subtend theta at the other end. But, and I should zoom in a bit so that you can see. But this angle is vertically opposite. So this one is also theta. So in this particular triangle, this angle will be theta. Same way, if I assume this to be alpha, this chord is making that angle over there, so this becomes alpha. But this is also alpha. If this is alpha, this is also alpha. So here also you get alpha. So now you see that both these triangles have become similar. They have same angles. This one is vertically opposite. The other opposite two angles are also same, theta and alpha. So the sides should be in the same ratio. So you have been given the sides, 3 sides, and you need to find the fourth one. Sorry. So what we have been given is this one is 4. So opposite to theta and opposite to theta, so that becomes 10 by 4 is equal to opposite of alpha, which is 8 divided by opposite to alpha by x. So actually, Rendu, your answer is not correct. I also, I thought you did it correctly, but the answer here would be 3.2. So we get 3.2. Now, do you know why we got 3.2? It should be clear ideally now that we have done it. I know, Pendu, why you got 5 and what you were thinking, but that's not the question. But now is it clear? We have used the alternate segment theorem. We just assumed a tangent and then we said that if theta is the angle created by this chord on this side, then theta would be the angle subtended over there. And same way, because theta is the vertically opposite angle, this one will also be subtending theta. And using this, we realize that these two triangles are similar. And if these two triangles are similar, then we can use the ratio of sides to get the answer. moving to the next thing. So there are only two properties. I won't go and solve questions on these, but need to know this. We'll solve all the questions on these in the next session. But you need to know this: pt square is equal to pa into pb. So if there is a point and we have a tangent here, then the length of, say, let this tangent were 10 and this length pa were 8 from here to here, then you can find AB. PT square, which is equal to 100, is equal to PA, or this particular length, multiplied by PB, or the total length. So from here you can get, if this is 8, then PB will be equal to 100 by 8, or whatever it comes to, 12.5. And so if you wanted to calculate this thing, you can say that this will be 4.5, because this is already 8, so this is 4.5. So this is a relation, very useful relation. We use it many a times. PT square, if from an external point a tangent is drawn, then the square of length of that tangent is equal to, if you draw a chord from that point, PA into PB. And since it will be the same for all the lines, you can also see this one becomes very important. PA into PB is equal to PC into PD. So if I draw another line which is PC into PD, or if I draw a third line which cuts at E and F, then we can also say this is also equal to PE into PF. And इसका derivation भी है. We won't go into the derivation a lot. If you need, you can read up on the internet, but I think you can manage without knowing this derivation. So questions we'll do in the next session on this one. There are these kind of things also. So that's for external point. Internal point के लिए भी हो जाता है. If there are two chords which intersect themselves at point O, then you can say that BO into OC will be equal to DO into OE. So if I were given lengths, this is 4, this is 6, this is 8, and I want to calculate what will be this length X, then you can say that that length will be 4 into 6 divided by 8, because 8 into X and 4 into 6 will be the same. So that length will be 3, and that holds true for all. I think this is what actually Pranendu was doing. He was confused between this question and what was coming, because the figures looked fairly similar, but it's a completely different situation. If you want to know the derivation, थोड़ा सा derivation इस type का ही है. You make these triangles, and then these triangles become similar to each other, because they are the same arc subtending angle. So this becomes theta, so this also becomes theta. That subtends alpha, so this also becomes alpha. So these two triangles become similar, and then you can say that the sides are in the same ratio. Not needed, but if you need to, you can do such things. So I think I'll stop here. We started a bit late, but I think I went through it reasonably quickly, although I hope things were clear, because they were not very difficult. We were not going into a lot of difficult questions which had very complicated concepts. So in general, the concepts will be the same, but the way you can make things difficult is by putting in 3 or 4 concepts in one question, and that would make things a bit more complicated. We'll see all that in the next class, but we'll use all the things that we have discussed today fairly easily in the next one. So if you are not comfortable with that, you will find things difficult. So you need to revise all the properties that we discussed today, all the questions that we discussed today. Anushka, I generally keep it on Sundays, but I could keep one tomorrow also. I want to get through the syllabus as quickly as possible. So let me think about it tonight. But most probably it will be next Sunday around this time, next Sunday at 10 p.m. But there is a slight chance that I might have one tomorrow as well around 10 p.m. So if that happens, I'll put up an event and put up a post. If nothing, then it will be next Sunday. So next Sunday we do circles. Again, we do only questions, mostly a few concepts here and there, but mostly questions. And then so after circles we'll do quadrilaterals a bit, and polygons पे भी थोड़ा सा time we will spend. Polygons में we'll spend like 15-20 minutes, but quadrilaterals we need around 1.5 hours at least to go through them. So that will be then, and then there is a session on mensuration which we need to have, areas, volume, and so on. So these things we need to complete, post which what we have left in the course is probability, permutation, combination, and set theory, which we come to after that. So that's the thing. I wanted to get it over with by August end or mid September. But if we do one class every week, it might go till September end, as I was calculating today. So let's see. We'll see how it works out, because people also get tired having classes every day. Plus, on Monday there is generally very low attendance. So we'll see. Anyways, thanks for attending. Please revise these things. Otherwise, there is no benefit. I keep repeating that and still nobody revises. But I'll still repeat that. Revise, get these things by heart. Then only there is a benefit of you being able to perform during the exam within time constraint under tremendous pressure. It's very easy to solve questions at home when you take 30 minutes to solve one question and also refer to the formulas and look back at what you have done earlier and everything. But in doing the exam setting, it's much more tougher. And for that, you need to be an expert. You need to know everything by heart. So you need to do all that. Thanks for attending. Thank you very much. I'll close now.